Hi, my name is Corey Wadeen. My partners Amy Stores and Tyler Tucker and I are going to go over Chapter 9, Create the Foundations of Our Deployment Pipeline. Now, the first slide is going to be the introduction. Pretty much this chapter talks about how we implement things into existence from the creation process. Now, say we have a project that we've been working on for the last 2 years or last couple months, and we haven't put it into a real life scenario. Well, how are we going to know what bugs to fix, what the developers can do to help make the problems better, and what we need to get from our feedback to help improve our system? We also need to make sure that our system is reliable. We can't have a faulty system at the start date. That just would be unacceptable in a professional field. Now, it's important that we run our product in test environment or a simulation that is like real life environment. So we're going to begin with the first slide, enable on-demand creation of development, test, and production environments. Now, the major contributing cause to chaotic software is how it reacts in a real life situation. Now, this is important because if we released, say, for example, Netflix released a new software update, and that software update crashed the system. Well, wouldn't it have been smart to test that software update before implementing it into a real-life scenario or releasing it to the public? Well, if we did this, it would give developers time to fix the bugs. Now, if the bugs aren't fixed, the product's not going to work properly. So this is important and vital to every release of a software. We also need to be able to create new environments quickly. If we can't fix these problems quickly or in a timely manner, it can delay the project and cost the company hundreds, if not thousands, maybe even millions of dollars. Next, I'm going to pass the next slide over, which is create our single repository of truth for all systems, to Amy Stores. Go ahead, Amy.
Thanks, Corey. Now for creating our single repository of truth for all systems. First and foremost, we just have to realize that version control is an essential part of the single repository for all systems. Because with version control, we're going to be able to back up and record all of those changes to a single file, a group of files, for everything from the file itself to who made the change to when the change was made. This will be a benefit for multiple different areas, from troubleshooting to maybe doing a comparison for future code changes, to merging with other code. Version control will help us do all of those things. And we like to think that version control should just be for a production environment, but we actually need to keep it for a dev and a test environments as well. So that's going to include the software, the hardware, the operating system, all of our documentation, because really that's where it starts. It starts when we're developing it, and it continues when we're testing it. So we want to have that version control at each step along the way, so we can revert back if there's a problem. We can more easily do comparisons. It'll help us for our current builds and for future builds. So I really like the Puppets Lab 2014 State of the DevOps report, when they said that the use of version control by ops was the highest predictor of both IT performance and organizational performance. I thought that's very insightful as to not just that it's a simple thing of version control, but that it actually has a larger outcome for the entire project, current and future. So let's actually move on and look next at making the infrastructure easier to rebuild than to repair. So first, I think it's also important to understand that repairing takes a long time, trying to find the issue, repair it, and then once you repair it, say in the production environment, then we have to do the same thing and go find it in the test and the development, because by then many other things have been developed. So we kind of looking for that needle in the haystack at that point. So having a system that allows us to just rebuild rather than repair is invaluable. So when all the changes can replicate automatically, then we're able to truly see the benefit of the building instead of repairing. So that's where immutable infrastructure comes in. So we get to a point where we need no manual updates. all of our updates will actually be automatic. And we see later on in the reading that Google was a prime example of how that system really became successful, not just to fix their current problems, but in making them and all of their changes happen so fast that moving technology was not a problem for them anymore. Information changing in a moment was not a problem. So coming back to where we are with this, we're looking that we want to ensure consistency between that dev, the test, and the production. So unfortunately, human error doesn't allow for that. So just having all of the changes done automatically and automatically replicating is the only way to make sure that we have that consistency. It also will help us so that we don't have variances between the test environment and the production or development and production, because we are seeing the same changes replicate in each of those different areas. And once you have it so that the system is working well and has a process to it, it also motivates everyone to use the process within the version control, because then their stuff is being tracked and it's being implemented quickly, and it's giving them the opportunity to continue the build. So it ends up being a win-win for everyone. And now I'm going to turn it over to Tyler.
Alright, so next we need to modify our definition of done to include a running production environment. Really, we want to have a production environment throughout the entire process. So it's not just having the code done working on developers' laptops, or development environment, or production-like environment users would use, ready to deploy whenever, to make sure that it works in a variety of environments, running it hundreds, even thousands of times to build confidence that it's going to work. We want to use the same tools in pre-production as in production, just to keep up the consistency and to no chance of errors or moving down the line. Similar to game telephone. In conclusion, we want to, as I said earlier, use a production-like environment in the process, reduce the risk of problems, especially later on in the road, rather than having to reverse engineer and go back several steps and see what happens. But redefine what done means. We'll ensure that the code is properly tested, realistic environment for deployment, and replicate changes to all non-businesses. Thank you very much.